Hey, this is OXDF, and today we're looking at Advent of Code 2022, Day 21, Monkey Math. So the monkeys from previous problems are back, I guess. Basically, we're going to get a list of monkeys here on the side, and each monkey is either going to have a number or it's going to be a combination of some other monkeys, right? So to find out what SJMN is, we need to know DZRM and DBPL, which is 5, and then but this one is 2 more, so we have to go, and so it's basically gonna be a tree that we have to evaluate. Um, and that's basically it for part 1. Everything will either be there's either going to be addition, subtraction, multiplication, or division, and the question is what is root going to get? So I think this seems uh, deceivingly simple. So let's give it a try. Looking over the input here, I will say that Genday script, there's a copy in the repo that's linked in the description below, and you can see some details in day 1 video. Pulls input, makes me a stub. So we have clearly a lot more monkeys, like almost 2,000 of them. The numbers are not too big. Let's see, we need to know, there's a root. That's what we need to find. Okay, then nothing seems too crazy here. We are going to basically set up a tree of monkeys where each monkey defines the other monkeys it needs to know, and then we are going to use recursion to call from root. So let's start with saying monkeys equals like that, and then we can say for line in lines. Better get the input back up here. Actually, I don't know how complicated this is going to be, but we'll put it in here anyway. Line dot split on space, and we want to, let's just do it once. In fact, let's split on colon space. That'll be easier. And so that'll give us m comma, I don't know, for like monkey, and then what are we going to call this other one? Expression. So then we can say monkeys sub m equals e. And that's probably all we'll do for now. We'll handle the rest of the making them into integers and processing them and stuff as we go. So now we can say, well, we'll do part 1 equals get val root. And that's all we need, right? So let's come up here and def get val on node, or I guess we'll call it m for monkey. And so the question is now, when we want to get a value, what are we going to do? Well, the first thing we can do is we say monkey, we'll say ex equals monkeys sub m. So we get the expression. We can do if is instance ex. Oh, no, that's not going to work. Let's see. We can do try ex int ex. I guess we would return int ex. I always forget the name of the expression, the error that gets thrown here. So let's save this. And let's just run it. Python there input.text, and we're gonna get expression value error. That is not a thing. Perfect. So we can say we could do just an accept all, but that's just such that just has bitten me too many times. So now we'll use this exception here, the value error. Probably learn this one. If it's a value error, pass will continue. Okay, so what are we gonna do here now? So now we're gonna say ex.split on space. We'll say tokes equals. I'm going to assert, because I'm making an assumption, that len of tokes equals 3. Basically, I'm saying, like, if it's not an integer, I'm assuming it's always going to have 3 pieces. I can say if tokes sub 1 equals plus that. Return int tokes sub 0 plus int tokes sub 2. I can do this. Whoa. And I can do this 3 more times. Let's see. If tokes of that equals minus. Probably could just do this in like an eval, but we're going to be good about it here. This and divided by, I don't know if I'm supposed to do integer division or just division. I'm going to try something here. Assert hooks. No, I'm not gonna mess with this. Okay, I was gonna do some kind of assertion to like say that these two things always divide each other, but we'll come back to that, I guess. So there we go. We should have. We should never hit here. Or if we hit here, we need to go figure out why. So that's basically it. Is it possible we just solved it? Let's see. Invalid literal from base 10. Interesting. Minus mpdb. Continue. Invalid literal for base 10. What is ex? Oh, of course. We're not doing int of these things. We're going to do get val of these things. There's the recursion part. So instead of, now, if it's an integer, if it actually works as an integer, it will, the first thing it'll do is return as an integer. But if it's not, it'll recursively get it. So let's try that again. All right, what do we got here? Let's see. Key error. Oh, we should do a strip on all these things. Let's see. Line dot strip dot split. Because we're getting a new line pegged to the end, and we have an answer. It's not a small answer, but we can give it a try. We got it. All right, not too bad. Pause while I read this. Okay, so there's a few things we're going to change. Root is no longer whatever it was before. It's now going to have an equal sign as its operation. And it's going to be checking to see if the two numbers given to it are equal. The other thing is there's one called human, which is me. And I'm guessing it's got a number. Let's check that. 726. Okay, so that number is not 726. That number is whatever I want. I get to choose. And the goal is that I get to choose a number so that root passes the equality check. Yeah, the number after human is now irrelevant. Okay, so this could be hard or easy depending on what they pick. So we'll come up here, let's see. We will say get val h equals none. I guess we'll call it HUMN equals none. Then we can say if HUMN, that means we're in part 2. And m equals root. Huh. I guess I can make a whole new function. It feels kind of lame to copy and paste that. I guess I'm gonna do that for now. I'm gonna make a get val 2. We can always come back and figure out how to combine them at the end. I don't know if that'll be an interesting exercise or not. Well, to see depending on how quick this goes, we'll see if let's see if we want to. So we have HUMN. Okay, so we call get val 2. Now we're gonna get for the monkeys thing, we're gonna say if m equals HUMN, return HUMN. Okay, so real quick, if we get down, so basically what we're gonna do is we're gonna still call this with root, and root's gonna still evaluate through, but whenever we get to one that's human, we're just gonna return the number we're passing in. If m equals root, return, and root is clearly not going to be two numbers, so we're going to say return get val2. I guess we can put this down here. Let's see, after we get some tokens here, down here, if m equals root, we're going to return get val2 on tox 0 equals get val2 on tox 2. And now otherwise we're going to be exactly the same, except for these should all be 2. And they should all pass human. So we'll grab this right here and copy. Again, there's probably a cleaner way to do this, but okay, so now we're doing the whole, we've got this set up. If we call get val2 with the value that human was before, so 726, we should get the same as part 1. Verify that. Oh, we get false because they're not equal. Let's just to make sure let's try that. Yeah, okay, so that looks like it's working okay. Okay, so let's say for I in range, I don't know, negative 10,000, 10,000. Let's see how fast this runs. If get val2 on I break part 2. Let's try that. Oops. Maybe that's too much. Okay, so hit 999. What we really can do here is else assert false. That way, so the else is only going to run if the loop doesn't break. So this will show us like, yeah. So we hit an assertion. So it's not in the number is not in this like thousands here. Let's see, what can we do? We need to figure out how to find this thing. I'd like to look at the results. Let's see, where's root? To do this. V1 equals this. V2 equals that. Return V1 equals V2, V1, V2. Okay, so now we'll get all the results. We'll see how close we are. And so what we really need to do then is equal V1, V2 equals that. If equal break, but we know it's not. And let's see, we can come here and we can do print. What are we going to print here? F will do part 2 V1 V2 V1 minus V2. Try that and see how we're going. So I'm put this into less. Let's take a look. So we started with 1,000 and our numbers were huge here, and we're getting smaller. Is it definitely going down every time? It is. So we're going in the right direction. We're just not going in the right direction fast enough. So we could do. We're continuing to go down. I don't know if I can do some kind of like, I guess I could, Yeah. So I think we're okay. So let's try like more. Let's try a binary search in here in this space. So we can do. Let's see. So we're not gonna do it. We're not gonna do our for loop anymore. We're gonna say start equals. We'll say guess equals 0. We will do while. What are we checking here? Oh, I guess we need like a low and a high, right? So low equals 1 e negative 1 e 9. We should be able to go through a lot of space, right? High equals 1 e 9. While high minus low is greater than 0. Feels a little scary to me, but is well, is greater than, yeah, okay, we'll try that. Is greater than 0. So well, we're gonna we'll say we will do this on yes. So we will say if v1 minus v2 greater than, so we're going to get our thing. If we want to check how we, man, I haven't done a binary search in a long time. So we're going to start with the point at 0. If our number is too high, meaning positive, we want to bring low up to the midpoint and check the new midpoint. So this is okay. This is going to be mid. Okay, here we go. So here's our thing. We will pass the midpoint in. If we're too high, we want the midpoint to come, we want the input to be lower, I believe. That we figured out in this less. Let's figure this out. If we increase, we want to increase it. Okay, so that means we want that's greater than 0. Then we want low equals to mid. We want mid equals to high plus low divided by 2, like into the middle, the average. Else oh, well, okay, else we want the high equals to mid, and then we want the same thing. We're going to make this the new average, so we'll bring this down here. And are we done? I think the only other thing we need to do is if equal, this is messy, I realize, but we're just going to break. Okay. And we will print mid v1, v2 and see where we're going here. Assertion error false. That hit very quickly. Didn't even print anything. Oh, because let's get rid of this. We're in a while true loop, so we should wait a long time. Part 2 is not defined. Okay, we don't need you yet. Nothing. We're not running. I clearly screwed something up in here. Let's get the PDB on 71 minus C break on 71 minus CC. Never hit. I probably haven't saved. No. Well, high minus low is less than 0. Greater than 0. Okay, so we have something here we can play with. So we start off at 5,000. 5,000. I guess we started off at 0, went up to 5,000. We're going higher and higher. And we're getting up to a higher, and we're not getting any closer. Are we? Let's see. So we are. The number is going down. We're just not high enough. We gotta start our search bigger, I guess. Okay, so are we getting? Our numbers are going towards 0. We do hit an endpoint here with it at 16. I guess we should note what mid is here. Is part 2 equal to mid? That runs quickly. We got a number. It's kind of messy. Yeah, let's see if we. Nice. All right. So I'm gonna let's go back and take a look at cleaning up this code a little bit. So we'll say, well, true. Don't need this print. If equal break again, we don't need that. So what we're going to do is we're starting off basically at 0, and we're going to check. We're assuming that we're making an assumption that this is monotonic, which means it's like increasing or decreasing. Well, I guess decreasing, we know. So if we get a solution and it's equal, we're done, right? So we're done. Otherwise, we will, if we are too high, we will move our lower endpoint up and then move our midpoint back in. So we're kind of dividing the space. You know, if the space is this whole thing, we start with the midpoint here. If we need to be higher, we move the low point up here, move the midpoint to here, and then we can like continue to cut the space in half until we get there. And you can see that's very quick. You know, we start off with these being 10 to the 16 apart, and then we quickly settle in, not too long. All of a sudden now we're down to like 37,000 apart, 400 apart, 200 apart, 65 apart. You know, we get down to, and eventually we get 0. So we don't print there. We could put that print. Oh, well, we took the print away, but yeah. So now we can run this. It runs fairly quickly. I thought I took the print out. Yep. Okay. So there we go. We can do, you know, both parts here in less than a tenth of a second. So that was kind of a neat challenge. Nothing else to say, I guess. Thanks for sticking with me today, and talk to you tomorrow.